Yes, that's an exclamation point.
Exclamation point. Guys, we're so
Brat.
happy it's
Todd.
no. Oh my gosh, what is her middle name? No. It was an R, I'm pretty sure. That's why I thought it was the same as yours.
Renee.
Yeah, I thought it was Renee.
Okay. G of X, Brooklyn.
1.
Oh. Yes, Brooklyn, sorry. Lilies, the limit as X approaches 6 from the left. 4, very good. As it approaches it from the right, Steve? -2. So, what's the limit there, Ashley? Does not exist. They're not the same. So, is it continuous when?
No.
Woohoo. Is that better, Todd?
Yeah. No.
I like that one. That was my favorite. That was
Thank you. All right.
1.
G of 8. Faith.
-5.
What?
Close.
-4.
There you go.
I can't read these graphs. Me either.
G
I
of
did 6 look the same.
8. 8 is right here,
Oh.
which is at -4.
I read it wrong. Oops.
That's okay. What's the limit as X approaches 8 from the left, Lilies? Very good. From the right, Todd?
-2.
That's going to become a habit. Steve, what's the limit?
-2.
So, everybody, is it continuous?
No!
No!
Pretty exclamation point.
So, looking at the...
That one is the only one that doesn't have an exclamation point.
She's going to have an attack if you don't put it.
I was like, do not put it in highlight.
Okay, so only this one
It's continuous.
was a yes. So let's look at what's going on. For the first one, what has to be true?
It has to have a limit. Or it
has to be defined.
It has to be defined. So we would say that f of a or g of a or whatever it is must be defined. Then, what do we know?
They have to be the same.
Yeah.
Yeah, those limits have to be the same.
Well, doesn't also the G of whatever, the point have to be the same?
Mm-hmm. So limit as X approaches A from the left must equal the limit as X approaches A from the right equals some number. So the limit must exist. And then you were telling me what else?
Well, like G of 0 equals -1.
Yeah, so then f of A has to equal that limit.
Oh.
Yeah.
Cool, yeah.
So we know in our head what makes a graph continuous. Now we have it in words. This is what makes it continuous.
And then we're going to do math, aren't we?
We're going to have to show why something is not continuous and use these
Because
rules.
it doesn't
And you
follow
can't
the-
say because of number 1. You have to
Because-
state what it is.
Because it's not a line.
No, you have to use one of those rules.
But it's not a line. So.
So on the back of this, the graph of the function, this is g of x. Is it the same graph? No.
No.
Has several x values at which the function is not continuous. For each of the following x values, use the 3-part definition of continuity to determine if the function is continuous or not.
Well, the first one's not.
Teachers and students, pardon the interruption. We are going to begin bus evacuations now. Teachers, if you're having a test at this moment, you may keep your kids in class. But at this time, we're going to dismiss 9th grade students who do not ride a bus to school or home from school or any athlete. If you ride a bus to school or home from school, or you are an athlete, you are exempt from today's drill. This is only for students who ride or drive vehicles or ride in a vehicle and walk to school or home. If you ride a bus to or from school, or you are an athlete, you will do your drill at a different time. At this time, ninth graders who walk to school or are a car rider, please go to the bus loading area for a bus evacuation drill.
I promise you, there are still people that are calling the bus right now, or calling the office right now going, what?
I was gonna say, yeah, that's, he has to do that so people understand.
Exactly, and people are still not going to understand. G of negative 8. G of negative 8. Is it defined?
Yeah.
Yes, it is defined. What is it?
At this time, seniors who are car riders or walkers, please dismiss to the bus loading area for the bus evacuation.
It'll be really quick.
Seniors at this time with ninth graders.
Okay.
Yes.
If you play sport, you don't have to go. Right.
So, okay.
So there's number 1. We good with that?
I'll make up a sport.
What?
I'll make up a sport.
Number 2. What are the limits? The left and the right sided limits.
-5.
Okay. As x approaches 8 from the left-hand side is -5. What about from the right-hand side?
I think it's also,
Don't doubt yourself.
I was pretty sure it was.
Yeah, -8. Yeah, it's approaching the same thing from the left and the right. So it is.
Where is -8?
It's the second to last number.
Wait.
Okay. Cool.
See it?
Oh, it was -8?
It was.
Okay.
Sorry. And that's -5. So then that means that the limit does in fact exist. Limit as x approaches -8 of g of x is -5.
No, it's not.
Yeah, number 3, g of -8 is not equal to that limit. So because of that, therefore, I don't know if you know that, those 3 dots, that means therefore,
Oh, lit. I'm gonna use that now.
g of x is not continuous at x equals -8.
Who decided that those 3 dots were there for?
Is that?
Mathematicians.
That's probably. Oh,
Does it work in
not
English?
Braille.
Mm. It's not what?
Braille, like for blind people.
I don't know.
Braille is so cool.
Let's look. Let's look it up.
Okay, no, we don't have time. Sorry. Number 1 here. Does g of -6, is it defined?
At this time, juniors who are car riders or walkers, please dismiss to the bus loading area for a bus evacuation drill. Juniors that are car riders or walkers only. Thank you.
I play sport too.
G of -6,
You're welcome.
that's over here, is down here at -7. So yes, it does exist. So it is defined. And its value is -7. What about the limits as x approached -6 from the left and from the right?
-7.
Also -7.
Yeah, it's the same thing. That's wonderful. So that means that the limit as x approaches -6 is also -7.
Woohoo, they do continuous.
Yeah, these two do equal each other. They're all -7.
Yeah.
Woohoo! See? Fun. So g of -6 is equal to the limit as x approaches -6. Therefore, g of x is continuous at x equals -6.
I made it a point to finish writing before you did.
No!
How do you finish writing before free?
My hand is dying over here, too. Okay, you do the last one.
Like, I don't want to write no more.
Dude, I don't want to write no more either. Just call me dude.
You just call me dude.
Yep, she's the teacher.
Thank you for that qualification, babe.
You're welcome.
I appreciate that.
I mean, I had the same problem last year, and I took you to wait so I could take.
I was like, babe.
You told her.
Yeah, y'all weren't in the class. I was texting or like on a calculator or something, and she told me to put up my phone, and I said, "Wait 1 moment."
It's like, have y'all seen Jumanji? The next level? It's like the girl when they're like, do you realize it was a math class too? And I think of myself every time I see that teacher. And she's like, do you realize there are other people in the class taking a quiz? And she's like, I'm having female issues, and as a woman, I would think you would understand. She's like, that's detention.
I've never been put in detention.
Okay. Ashley, you have detention.
Teachers, at this time, please dismiss 10th graders to the bus loading area who are car riders or walkers. Thank you.
Technically, I am in detention today
Can you
because I have to
scroll
go
over the word?
keep junior high.
As I somehow got
Oh my gosh,
sick.
can I come?
No.
I think I'm a great example.
It is
Say.
6.
No.
Does that help?
Yeah.
Okay.
See, most of my childhood was in detention, so
I got put on the wall once at like 3rd grade.
Oh, no.
I got put on the wall because you had to walk quietly from the cafeteria to recess, and I whispered to my friend, and I got put on the wall, and I cried for an hour.
Yeah.
that's funny. I've never cried because of it.
And they were like, you weren't really talking, but we had to set an example. I was like, why do you have to take me?
Poor
I
kiddo.
had my